word in organic chemistry, isomers. And I do have a typo here, so let's get that changed right away. It should say isomers. Sounds a lot like that other word, isotopes. So, isomers refer to organic structures. If two structures are isomers, they have the same molecular formula, but they have different structures. And when you change a bond, when you change the structure, these molecules are considered different substances. And they will have different properties. They will have different names, and how they are used in industry will also be different. As you increase the number of carbons in the molecular formula, you increase the possibility of possible number of isomers. So the larger the molecular formula, the more possible isomers. So let's take a look here. Here is my molecular formula. Okay, so this is a molecular formula. And I'm going to show you how we can put these atoms together to create a structure. So I can start off with 2 carbons. I'm going to link them with single bonds. Okay. My first carbon, I'm going to add 3 hydrogens to it. My second carbon, I'm going to put the only oxygen to it. I need 3 more hydrogens. So that carbon, second carbon, besides the 1 oxygen, I'm also going to add 2 hydrogens. Oxygen, being in group 16, it has 2 unpaired electrons, 2 move from the noble gases. It requires 2 bonds. So there's my 6th hydrogen. If I do the condensed structural, it'd be CH3, CH2OH. Now, second structure, same molecular formula. This time, instead of linking the 2 carbons together, I'm going to build the molecule around the oxygen, and the oxygen needs 2 bonds. And on one end, I'm going to put a carbon, and on the other oxygen bond, I'm going to put the other carbon. So my oxygen has 2 bonds. Each carbon only has 1 bond, so they each need 3 more, but I have 6 hydrogens. So I'm going to fulfill each carbon's bond need with 3 hydrogens. And when I do the collapsed condensed structural formula, I see CH3OCH3. So the structures here look different. The condensed structures also look different. There's a different sequence in those. This first structure here is known as ethanol. And the second structure is known as dimethyl ether. Ethanol, this is the only alcohol that humans can drink in moderation. All other alcohols are very toxic to humans. And dimethyl ether, it vaporizes very, very quickly, and if you inhale it, it really irritates your respiratory system. And if you inhale enough of it, it can actually knock you out and even cause death. So take a look at these 2 practice questions. It asks you, explain if the following structures are isomers. Okay, so isomers, they have to have the same molecular formula. So if I take a look at this, this is C3H, 1, 2, 3, 4, 5, 6, 7, 8, O. Here's this molecular. C1, 2, 3, H, 1, 2, 3, 4, 5, 6, 7, 8, and O. So they have the same molecular formula. Now I'm going to look at the structures. I notice here I have a 3-carbon chain with an OH. In here I see the oxygen breaking up the carbon to carbon chain. So they have the same molecular, but they have different structural formulas. So yes, these are isomers. Now if you take a look at the next one, okay, are these isomers? Well, take a look here. I see I have C3, and here I see C2. Right there, they have a different carbon count. So they have a different carbon count. Therefore, they do not have the same molecular formulas. So these are not isomers.